July 26, 1944. Near Saint-Lô, Normandy, France. 1,547 hours. Oberleutnant Karl-Heinz Becker crouches in the commander's cupola of his Panzer IV, scanning the bocage hedgerows through Zeiss optics that have served him faithfully since the Eastern Front. The afternoon sun casts long shadows across the Norman countryside, turning the ancient hedgerows into walls of green darkness that could hide an entire army. His crew has been at war for 4 years, veterans of Poland, France, and 2 brutal winters in Russia. They know their tank, know its capabilities, know the dance of armored warfare where positioning and the first shot mean everything. Through the haze of summer heat and dust, Becker spots movement. 3 American M4 Sherman tanks emerging from a tree line 600 meters distant, moving at speed across an open field toward his position. His gunner, Underoffizier Steiner, already has a lead Sherman in his sight picture. Becker feels a familiar cold clarity of combat settle over him. The Americans are moving, a tactical error that every Panzer commander learns to exploit in training. A moving tank cannot fire accurately. The Sherman 75mm gun, already inferior in penetrating power to German tank guns, becomes nearly useless when the tank is in motion. Standard doctrine, proven doctrine, halt, acquire target, fire. The Americans are closing the range, but they are moving, which means Becker's crew has precious seconds to achieve a killing shot before the enemy tank stop and return fire. Steiner adjusts his aim, compensating for range and the slight angle of the target. Becker's hand moves toward the firing command. Then, impossibly, while still in motion across rough terrain at perhaps 25 kilometers per hour, the lead Sherman's turret traverses smoothly and its main gun flashes. The sound reaches Becker a half-second after his Panzer shudders violently. Something has punched through the frontal armor that should be proof against the Sherman's gun at this range and angle. The interior of the tank fills with smoke and the terrible sound of metal fragmenting inside a confined space. Steiner slumps forward, killed instantly. The loader screams. Becker's mind cannot process what has just occurred because it violates every principle of tank warfare he has learned. The Americans fired while moving, and they hit, accurately, lethally, as his driver throws the transmission into reverse and his training takes over, as he orders the evacuation of his burning tank. One thought cuts through the shock and pain. Nothing in 4 years of armored combat had prepared him for an enemy who can shoot accurately while in motion, who can violate the fundamental rules of tank warfare and succeed. The Americans have changed something essential about how armored combat functions, and German tactical doctrine has no answer for it. What do you think allowed the Shermans to achieve something German tank doctrine deemed impossible? Was it merely better crew training? Or had the Americans engineered a solution to a problem German designers never considered worth solving? Consider what you know about tank combat, about the difficulty of hitting a target from a moving, vibrating platform, and ask yourself, what technology could make the impossible routine? The story of how American Sherman tanks came to dominate German panzers through the revolutionary capability of accurate fire, while moving begins not on the battlefield of France, but in the engineering offices and proving grounds where American designers approach the problem of tank warfare from fundamentally different perspectives than their German counterparts. The M4 Sherman has been maligned in popular history as inferior to German tanks, outgunned by Panthers and Tigers, under-armored against German 88mm guns, relegated to winning through numerical superiority rather than technical excellence. This narrative contains truth but misses the essential innovation that gave Shermans a decisive tactical advantage in combat: the gyro-stabilizer system for the main gun, a technological solution to the problem of mobile gunnery that transformed how tank battles were fought. German tank design philosophy emphasized firepower and arm protection, creating vehicles that were formidable in static gunnery duels where positioning and the first shot determined victory. The Tiger could kill a Sherman at ranges exceeding 2 kilometers. The Panther's sloped armor could deflect Sherman rounds that struck at oblique angles. German optics were superb, German gun laying systems precise, German ammunition well designed. But all of these advantages assumed a particular kind of engagement. Tanks would maneuver for position, halt to fire, then move again to avoid return fire or reposition for another shot. This was sensible doctrine based on the mechanical realities of tank gunnery, A gun mounted in a vehicle traveling over rough terrain experiences constant vibration and displacement that makes accurate fire nearly impossible. Every tank force in 1944 accepted this limitation and built tactics around it. Every tank force except the Americans. The M4 Sherman was equipped with a Westinghouse gyro-stabilizer system for its main gun, a complex assembly of gyroscopes, hydraulic actuators, and mechanical linkages that kept the gun oriented on target even as the tank moved over uneven ground. The system worked in the vertical axis, compensating for the pitch and bounce of the tank's suspension as it traveled. When functioning properly, the gyro-stabilizer allowed a Sherman to fire its main gun with reasonable accuracy while moving at speeds up to 15 miles per hour over terrain that would render any other tank's gun useless. The technology was not perfect. The stabilization worked in only one axis. Accuracy, while moving, was still inferior to accuracy when stationary, and mechanical failures were common in the harsh environment of combat. But it worked well enough often enough to provide American tank crews with capability no other army possessed: the ability to engage targets effectively without halting, to maintain offensive momentum while delivering fire, to shoot first in encounters where German crews were still executing the halt-aim-fire sequence that doctrine demanded. In the close terrain of Normandy's Bocage country, where engagement ranges often fell below 500 meters and surprise encounters were routine, this advantage proved devastating. Sherman crews could spot a German tank, slew their turret on the target as they continued moving, and fire, all while the German crew was still going through the laborious process of stopping their vehicle to achieve a stable firing platform. Those seconds of delay, repeated across hundreds of engagements, shifted the tactical calculus of armored combat in ways German commanders struggled to understand or counter. The development of the Sherman stabilizer reflected American engineering philosophy, applying technological solutions to tactical problems, accepting complexity and maintenance burden to achieve operational advantages, designing for the conditions of actual combat rather than ideal circumstances. The gyro-stabilizer was heavy, expensive, mechanically complex, and required trained maintenance personnel to keep functioning. German tank designers, operating under different constraints and priorities, had experimented with gun stabilization but deemed it impractical given the mechanical complexity and weight penalty. This was a rational decision based on their understanding of armored warfare and their industrial capabilities, but it was also a decision that left German tanks fighting according to doctrine that assumed both sides operated under the same limitations. When the Americans arrived in France with tanks that violated those assumptions, German tactical doctrine had no immediate answer. The first shot advantage that German crews had relied upon, achieved through superior optics and gun performance, became less decisive when American tanks could fire effectively while maneuvering, when German crews trying to execute proper gunnery procedures found themselves under accurate fire before they completed their own aiming sequence. Oberstfighter Ernst Barr served as a gunner in a Panther tank with the 2nd Panzer Division during the Normandy campaign. His account, recorded in a post-war interview, describes the confusion and frustration of encountering Sherman gunnery capabilities. We had been told the American tanks were inferior, that our Panther could destroy them with ease if we maneuvered properly. This was true regarding firepower and protection. Our gun could penetrate their armor at ranges where their gun could not harm us. But in the bocage, in the close fighting around the hedgerows, we rarely had the luxury of long-range engagements. The Americans would appear suddenly from behind cover, and before we could halt and lay the gun properly, they were firing, not wild shots, aimed fire, deliberate fire, while they were still moving. I saw a Sherman destroy 2 of our company's tanks in less than a minute, both kills achieved while the American tank was in motion. My commander kept shouting that this was impossible, that they could not hit us accurately while moving, but they were hitting us. After the 3rd tank in our platoon was knocked out by a moving Sherman, we stopped trusting what we had been taught about American capabilities. The enemy had something we did not have, some system that allowed them to shoot while moving, and it killed many good crews who followed doctrine and died while trying to execute proper gunnery procedures. What do you think it does to a soldier's confidence when the enemy demonstrates capabilities your training insists are impossible? When doctrine becomes a liability because it fails to account for technological advantages you did not know existed? How quickly can veteran crews adapt when their experience suddenly becomes outdated? The mechanics of the gyro-stabilizer system reveal the sophisticated engineering that American industry brought to bear on the problems of mechanized warfare. The system used a spinning gyroscope to establish a stable reference plane independent of the tank's movement. As the tank pitched and bounced, sensors detected deviations from this stable reference, and hydraulic actuators automatically adjusted the gun's elevation to compensate. The system could not eliminate all motion. Traverse stabilization was not included in most Sherman models, and rapid lateral movement still degraded accuracy. But by compensating for vertical displacement, the system reduced a major source of aiming error and made it possible for a competent gunner to achieve hits at combat ranges while the tank was moving. The system required the gyroscope to be spun up before engagement, demanded proper maintenance to function reliably, and was sometimes switched off by crews who did not trust it or who found it interfered with traditional aiming methods. But when it worked, and in American service, it worked often enough to matter. It provided a decisive advantage in the chaotic, close-range tank combat that characterized much of the fighting in Western Europe. The contrast with German gunnery systems was instructive. German tanks featured excellent optics, precise manual gun-laying mechanisms, and sophisticated range-finding equipment. The gunner station in a Panther or Tiger represented the state-of-the-art in fire control for static gunnery. But it was optimized for the halt-aim-fire sequence, for engagements where the tank would be stationary when the shot was taken. German tank doctrine emphasized this approach because it made sense given the available technology and the open terrain of the Eastern Front where much German armored doctrine had been developed. On the plains of Russia, where engagement ranges often exceeded a kilometer, the ability to achieve first-round hits at long range from a stable platform was paramount. The gyro-stabilizer offered no advantage in such conditions. Its benefits emerged only in close terrain, in meeting engagements, in situations where maintaining momentum while delivering fire created tactical opportunities. The Americans, designing for a war they expected to fight in the close terrain of Central Europe, prioritized mobile gunnery capability. The Germans, designing based on their Eastern Front experience, prioritized static gunnery precision. Both approaches were rational, but the conditions in Normandy favored the American design choices. The Sherman 75mm M3 gun has been criticized extensively in comparisons with German tank guns, and the criticisms have validity. The 75mm gun could not reliably penetrate the frontal armor of a Panther at combat ranges. The Tiger's armor was essentially immune to the 75mm except at close range and with perfect shot placement. Later Shermans received the more powerful 76mm gun, but even this was inferior in armor penetration to German 75mm and 88mm guns. But this focus on gun performance misses the systemic advantage the gyro-stabilizer provided. A Sherman might have a weaker gun, but it could bring that gun to bear more quickly and while maintaining tactical momentum. In the close terrain of the bocage, where hedgerows limited sight lines to a few hundred meters and tanks frequently encounter each other at ranges where even the 75mm gun could achieve kills with flank or rear shots, the ability to shoot accurately while moving translated into more first-shot opportunities, more targets hit before they could return fire, and a higher overall kill rate despite inferior gun penetration. The Germans had designed their tanks for one kind of war and found themselves fighting another, where their carefully engineered advantages in static gunnery became less relevant than the American advantage in mobile gunnery. Lieutenant Otto Carius, a highly decorated Tiger tank commander with over 150 confirmed kills, encountered Shermans repeatedly during fighting in France and later on the Eastern Front, where Shermans were supplied to Soviet forces under Lend-Lease. His memoir, written decades after the war, acknowledged the tactical challenge the Sherman stabilizer presented. The American tank was in many ways inferior to our Tigers and Panthers. Its armor was thinner, its gun weaker, its weight and size made it less survivable in direct confrontation. But the Americans used their tanks differently than we used ours. They would advance in groups, moving rapidly, and they would fire while moving. The first time we encountered this tactic, we assumed their gunnery was simply reckless, that they were wasting ammunition in panic fire. But they were hitting us. Not every shot, but enough shots to disable or destroy tanks whose crews were attempting to follow proper procedure. It forced us to adapt, to accept lower accuracy by firing while moving ourselves, to abandon doctrine that had served us well against Soviet tanks. The Sherman's ability to shoot while moving was, in the close fighting of Western Europe, more valuable than the superior performance our tanks could achieve when stationary. The stabilizer system became, in the context of Sherman operations in Europe, a symbol of American technological pragmatism and industrial capacity. It represented a willingness to accept mechanical complexity and maintenance burden to achieve tactical advantages, a design philosophy that prioritized practical combat effectiveness over theoretical performance metrics. German tanks were magnificent machines judged by specifications. Thicker armor, more powerful guns, better optics. But they were also mechanical nightmares judged by reliability and maintenance requirements, particularly the Tiger and Panther models that required extensive servicing and frequently broke down. The Sherman was comparatively simple mechanically. Its engine was reliable, its transmission robust, its systems designed for maintenance by crews with modest technical training. Adding the gyro stabilizer increased complexity, but American doctrine and training incorporated that complexity into the overall system. Crews were trained on the stabilizer's use and maintenance. Field maintenance units could repair or replace stabilizer components. The industrial system that produced Shermans produced stabilizers in quantity and supplied replacement parts reliably. The Germans could not have adopted a similar system even if they had recognized its value, because their industrial base was already strained producing existing designs and could not absorb additional complexity in manufacturing or field maintenance. The stabilizer advantage was thus doubly effective. It provided a tactical capability German tanks lacked, and it was a capability Germany could not easily copy even if they wished to. What do you think matters more in weapon design? Achieving superior performance under ideal conditions or achieving adequate performance under realistic combat conditions? Should tanks be optimized for the engagements designers expect, or should they include capabilities for situations that doctrine deems unlikely but which might prove decisive? The sound of the Sherman's gyro stabilizer engaging became distinctive to crews who fought in them, a high-pitched whine from the spinning gyroscope, the hydraulic hiss of the actuators adjusting gun elevation, mechanical sounds that signified the system was functioning and ready to provide its crucial advantage. For American tank crews in Normandy, that sound represented confidence, the knowledge that they could engage targets while maneuvering, that they did not need a halt and become vulnerable to return fire while laying their gun. For German tank crews who learned to recognize those sounds when they captured or examined knocked-out Shermans, those mechanical noises represented the answer to a tactical mystery, the explanation for why American tanks could fire accurately under conditions where accurate fire should be impossible. The sound of the gyro stabilizer became a symbol of American engineering, of the industrial capacity that could afford to install complex mechanical systems in over 49,000 Sherman tanks produced during the war, of a military that would accept maintenance complexity to achieve combat effectiveness. German tankers fought in vehicles that were marvels of design but which lacked this particular capability, and increasingly they recognized that the absence of gun stabilization was not merely a minor deficiency, but a significant tactical handicap in the type of fighting that dominated Western European combat. The tactical implications of the Sherman stabilizer extended beyond individual tank versus tank engagements. American armored doctrine emphasized momentum, the maintenance of offensive pressure, the rapid exploitation of opportunities. The gyro stabilizer supported this doctrine by allowing tanks to maintain speed during advances while remaining combat effective. German doctrine emphasized careful positioning, the achievement of tactical advantage through superior situational awareness and gun performance, the execution of deliberate maneuvers that maximize the strengths of German tanks while minimizing their vulnerabilities. The stabilizer undermined this approach by reducing the penalty American tanks paid for aggressive movement, by making their advances more dangerous to oppose because they remained capable of effective fire throughout their movement. German commanders found their carefully prepared defensive positions less effective when American tanks could advance under fire, shooting as they came, achieving suppression of defensive positions through the volume and rapidity of their fire, even if individual shots were less accurate than optimally aimed shots from stationary positions. Staff Sergeant Lafayette Poole commanded a Sherman named In the Mood with the 3rd Armored Division, achieving distinction as one of the most successful American tank commanders with over 250 enemy vehicles destroyed or captured during his service. His approach to tank combat emphasized aggressive movement and rapid fire, tactics enabled by the Sherman stabilizer. In after-action interviews, Poole described his methods. "We didn't stop to shoot if we could avoid it. Stopping makes you a target, gives the Germans time to aim properly. We would advance on positions, keep moving, and fire on the move. The stabilizer let us do that. It wasn't perfect. You couldn't hit a target at 1,000 yards while moving, but in the hedgerows we were fighting at 300 yards, 400 yards, and at those ranges you could hit. The Germans expected us to stop, expected to have time to aim and fire while we were going through our aiming sequence. But we were already shooting, already hitting them, and that disrupted their whole approach. Some German crews would panic and fire wildly when we came at them shooting. Others would stick to their training and try to aim properly, and we'd kill them while they were aiming. The stabilizer wasn't magic. It was just a tool, but it was a tool that changed how combat worked, and the Germans didn't have it. The maintenance burden of a stabilizer system was real and significant. The gyroscopes required careful handling and periodic replacement. The hydraulic systems leaked and needed constant attention. Electrical connections corroded in the damp conditions of Northern Europe. American tank units included maintenance personnel trained specifically on stabilizer repair, and supply chains delivered replacement components to forward units. Some crews disabled their stabilizers rather than deal with maintenance requirements, or because they did not trust the system's reliability. But unit-level data suggests that the majority of Shermans maintained their stabilizers in working order throughout combat operations, indicating that American maintenance doctrine successfully supported the system's operation despite its complexity. German forces, had they captured the technology and wished to implement it, would have struggled to maintain such systems given their deteriorating logistics situation and the declining technical sophistication of replacement crews as experienced personnel became casualties. The stabilizer represented not just a design choice, but an entire support infrastructure, engineering, training, logistics, maintenance, that had to function coherently for the system to provide its battlefield advantage. The contrast in design philosophy extended to other aspects of the Sherman versus German tank comparison. The Sherman was designed for mass production. Its hull was welded or cast. Its engine was derived from automotive production. Its systems were standardized across thousands of vehicles. The Tiger and Panther were semi-custom products, hand-fitted components, engines designed specifically for armored vehicles, systems that varied between individual tanks. The Sherman could be produced in vast numbers by factories converted from automobile production. German heavy tanks required specialized facilities and highly skilled labor. The Sherman could be repaired in field workshops with common tools. German heavy tanks required specialized equipment and factory-level facilities for major repairs. The Americans accepted that individual Shermans were inferior to individual German heavy tanks, but compensated through numbers, reliability, and sustainability. The Germans pursued superior individual performance and paid the cost in production limitations and maintenance difficulties. Both approaches reflected the industrial and doctrinal context in which they emerged, but in the grinding attritional warfare of 1944 to 45, the American approach proved more sustainable. What do you think the German tank crews felt when they realized that American tanks, inferior by every specification they had been taught to value, were nonetheless winning engagements through advantages that German doctrine did not recognize or counter? How does that realization affect morale, affect confidence in leadership, affect willingness to continue fighting when the tactical principles you were trained to follow seemed to guarantee defeat? By August 1944, German armored units in Normandy had been systematically ground down through a combination of Allied air superiority, artillery dominance, and the cumulative effects of tank combat, where American numerical superiority and the tactical advantages of the stabilizer system gradually destroyed German armored strength. The Falaise pocket encirclement resulted in the destruction or capture of hundreds of German tanks, many of them abandoned for lack of fuel or destroyed while immobilized by mechanical failures. The German armored force that had seemed so formidable in June had been reduced to scattered remnants by September, and the replacement tanks arriving from Germany could not compensate for the losses. American tank production, meanwhile, continued unabated, Sherman's lost in combat were replaced within weeks. Damaged tanks were repaired and returned to service, and the tank strength of American armored divisions remained relatively constant despite ongoing losses. The industrial disparity that allowed America to equip tens of thousands of tanks with gyrostabilizers, while Germany struggled to produce enough tanks of any kind to replace combat losses, ultimately proved as decisive as the stabilizers' tactical advantages. German tank commanders might possess superior vehicles on paper, but they fought with dwindling numbers while American armored units maintained their strength through an unending flow of replacements. The Eastern Front presented different conditions for tank warfare. Longer engagement ranges, more open terrain, battles and maneuver across vast distances. In that environment, the Sherman stabilizer offered less advantage because the ability to fire while moving mattered less when engagement ranges exceeded the effective accuracy of stabilized fire. Soviet doctrine with Lend-Lease Shermans emphasized mass charges and close assault, using speed and numbers of close with German tanks, and overwhelmed them through volume of fire rather than precision gunnery. But even on the Eastern Front, where the stabilizers' advantages were less pronounced, German commanders noted that American-supplied Shermans operated differently than Soviet-produced T-34s, that they seemed to fire more readily while moving, that their tactics emphasized momentum and aggressive maneuver. The stabilizer, even in conditions less favorable to its use, still provided incremental advantages that accumulated across hundreds of engagements. In Western Europe, where terrain and tactical conditions favor its use, those incremental advantages became decisive. The British Army, which operated large numbers of Sherman tanks alongside American forces, had mixed experiences with the stabilizer system. British tank doctrine emphasized different tactical principles than American doctrine, and some British crews found the stabilizer interfere with their preferred gunnery methods or proved unreliable in their service. British modifications to Sherman sometimes included disabling or removing the stabilizer system, replacing it with stowage or other equipment. This divergence in utilization reflected different tactical cultures and training emphases, but also demonstrated that the stabilizer's advantages were not automatic. They required doctrinal integration, crew training, and maintenance support to realize their potential. The Americans had built their tank tactics around the capabilities the stabilizer provided, had trained crews to use it effectively, and had supported it logistically. The British, integrating Shermans into a different doctrinal framework with different training emphases, sometimes found the system more trouble than it was worth. The technology alone was not decisive. It was a technology embedded within a supportive doctrinal, training, and logistical framework that created battlefield advantages. Hauptmann Heinrich Steinhardt commanded a company of Panzer IVs during the fighting in the Ardennes in December 1944, Germany's last major offensive in the West. His unit encountered Sherman tanks of the American 2nd and 3rd Armored Divisions during the battle, and his post-war account describes how German tactical adaptations attempted to counter the stabilizer advantage. By December, we understood that the American tanks could shoot while moving, and that this was not merely crew skill, but a technical system. We adapted our tactics where possible, attempting to engage at longer ranges where their stabilizer provided less advantage, trying to position for ambush shots where we could achieve surprise and kill them before they could return fire, using terrain to force them to slow down or halt. These adaptations helped, but they were defensive measures, reactions to American capabilities rather than exploitation of our own strengths. We were no longer fighting according to our doctrine, but according to limitations the Americans imposed through their technical advantages. This is demoralizing, to feel that you are always reacting, always compensating for enemy capabilities, never able to fight on your own terms. Many crews felt that the war had become unwinnable not because American soldiers were better than German soldiers. In individual skill and courage we considered ourselves their equals, but because American technology and resources created systemic advantages we could not match. The gyrostabilizer's whine, that mechanical sound of spinning gyroscopes and hydraulic actuators, became for German survivors of tank combat a remembered symbol of American technological superiority. Captured German tank crewmen, interrogated about their combat experiences, repeatedly mentioned the shock of being hit by accurate fire from moving American tanks. Intelligence summaries from 1944 and 1945 document German tactical discussions of how to counter Sherman stabilizer advantages. with recommendations ranging from longer-range engagement to more aggressive use of anti-tank guns positioned to catch Shermans before they could close to ranges where the stabilizer was most effective. But these were expedients, reactive measures that addressed symptoms rather than solving the fundamental problem. Germany could not field comparable technology at scale, could not provide its tank forces with similar capabilities, could not compete in the technical dimension that the stabilizer represented. German engineering could have developed stabilizer systems. The technical knowledge existed, but German industry in 1944 to 45 could not afford the complexity, could not divert resources from basic production to sophisticated enhancements, could not support such systems logistically given the collapsing state of German supply lines and maintenance infrastructure. By the final months of the war, as American and Soviet forces closed on Germany from east and west, the German armored force had been reduced to a shadow of its former strength. The few tanks available were often mechanically unsound, crewed by hastily trained replacements, operating without adequate fuel or ammunition, unable to receive maintenance or repair. The Americans continued to field armored divisions with full complements of Shermans, supported by comprehensive logistics, crewed by trained personnel, backed by air superiority and artillery dominance. The technical advantages the stabilizer provided had become almost irrelevant compared to the systemic collapse of German military capability. But for the crews who had fought through 1944, who had experienced the shock of encountering an enemy capability their doctrine insisted was impossible, who had watched comrades die because American tanks could shoot accurately while moving, the stabilizer remained a symbol of something larger. The demonstration that American industrial capacity could produce not just more equipment but better integrated equipment, that American military thought could develop doctrines that exploited technical advantages, that German tactical superiority and individual vehicle performance could be overcome through systematic advantages that changed the fundamental terms of combat. The Sherman tank, often remembered in popular culture as the inferior underdog that won through numbers rather than quality, was in fact a sophisticated weapon system designed around different priorities in German tanks, but arguably better adapted to the conditions of combat it actually encountered. Its stabilizer, a complex mechanical solution to the problem of mobile gunnery, represented the kind of engineering investment that only a nation with vast industrial resources and a willingness to accept technical complexity could afford. The fact that over 49,000 Shermans were produced with stabilizer systems, that those systems were maintained in combat across multiple theaters, that crews were trained to use them effectively, and that doctrine was developed to exploit them tactically, demonstrates the comprehensive nature of American military power in World War II. This was not merely industrial capacity or technical innovation in isolation. It was the integration of design, production, training, doctrine, and logistics into a coherent system that created battlefield advantages greater than the sum of its parts. What lessons do we draw from this story about the nature of military technology and its relationship to tactical success? Is superior performance on paper more important than practical advantages in realistic combat conditions? Should doctrine drive design, or should design possibilities reshape doctrine? The Sherman stabilizer suggests that the answers are complex, that effectiveness emerges from the alignment of technical capabilities with tactical doctrine and logistical support, that advantages in one dimension can compensate for disadvantages in another, and that warfare between industrial powers is ultimately decided not by individual weapon characteristics, but by the systemic integration of all elements of military power. In the years after the war, as military historians and veterans analyzed the tank battles of Western Europe, the Sherman stabilizer gradually received recognition as a significant innovation, one that contributed materially to Allied success despite being overshadowed in popular accounts by discussions of armor thickness and gun caliber. German tank veterans, writing memoirs and participating in historical studies, acknowledged that the stabilizer represented a technical advantage they had not anticipated and which they struggled to counter effectively. The M4 Sherman, evaluated comprehensively rather than simply compared specification by specification to German heavy tanks, emerges as a well-designed weapon system that prioritized reliability, producibility, and practical combat effectiveness over theoretical performance maximums. Its stabilizer, That complex assembly of gyroscopes and hydraulics that allowed it to shoot accurately while moving embodied a design philosophy that accepted technical complexity to achieve tactical advantages, that recognized the value of capabilities doctrine had not traditionally emphasized, and that demonstrated how industrial power could be translated into battlefield success through intelligent engineering and comprehensive system integration. The sound of the stabilizer, that distinctive whine that signified a functioning system and the tactical advantages it provided, faded from the battlefields of Europe in May 1945 when German resistance collapsed and the war ended. But the principle it represented, that gun stabilization could provide decisive tactical advantages in armored warfare, became foundational to subsequent tank design. Modern main battle tanks feature sophisticated multi-axis stabilization systems, computerized fire control, and the ability to engage targets accurately while moving at high speeds over rough terrain. These capabilities trace their lineage directly to Sherman's pioneering stabilizer, to the recognition that mobile gunnery could be engineered into practicality, that doctrine could be reshaped around new technical capabilities, and that advantages in one aspect of system design could compensate for limitations in others. The German tank commanders who never expected Shermans to fire accurately while moving learned, through bitter experience, that expectations based on existing technology and doctrine could be overturned by engineering innovation, that tactical advantages could emerge from capabilities that had seemed peripheral or impractical, and that winning armor battles required not just superior individual vehicles, but superior integration of vehicle capabilities with tactics, training, and logistics. In the end, the story of the Sherman stabilizer is a story about how wars are won in the modern industrial age, not through individual heroics or tactical brilliance alone, though both matter, but through the systematic application of engineering, production, training, and doctrine create comprehensive advantages that overwhelm opponents regardless of their courage or tactical skill. The German panzer commanders who fought against Shermans in Normandy were skilled, experienced, and equipped with vehicles that were in many ways superior. But they were defeated by an enemy who had solved a problem German doctrine had not recognized as critical, who had integrated that solution into their operational approach, and who could produce and support that solution at scale across an entire theater of war. The gyro stabilizer, that complex mechanism that allowed Shermans to shoot while moving, became the symbol of this comprehensive approach to warfare, a reminder that in modern conflict, victory belongs not to whoever builds the most impressive individual weapons, but to whoever most effectively aligns technology, tactics, training, and industrial capacity into a coherent system of military power. And in that contest, the Sherman's whining gyroscope and its battlefield advantages represented not American technological superiority in absolute terms, but American success in identifying what mattered in actual combat conditions and engineering solutions that translated industrial capacity into tactical effectiveness. This was a lesson German tank commanders learned, often fatally, in the hedgerows and fields of France, that their doctrine was obsolete, that their expectations were wrong, and that the Americans had changed the rules of armored warfare in ways that no amount of individual vehicle superiority or crew skill could overcome.